Yeah, hello everyone. Good morning. It's been really good for me to host this show, which is related to embarking on natural infrastructure, which is creating crafting a digital heaven. And in this infrastructure show, the audience can be able to learn a lot of things which are related to natural infrastructure services, which Microsoft, Azure. You're offering nowadays. Okay, and I want to wants to introduce our speaker Naveen Verma. Naveen is having around 5+ years of experience in his an organization called North Street Solutions, and he is also an Azure Developer Community Lead of the Gorgon. And he daily actually, if you see, Naveen will be sharing some bytes related to in natural infrastructure, which will be very much interesting to see, and we can get be able to learn everything on daily basis which are related to natural infrastructure. So what we have planned is actually, so if we organize a show like this which are related to the natural infrastructure, means actually it will be useful for many people around the world, and who are all following the Azure developer community as well. So Naveen, yeah, I'm very much glad to host you in this show, and I'm actually handovering the stage to you for the presentation. Thank you, everyone. Thank you.
Thank you so much, Saran. It's a pleasure to be on this show, and it's always great sharing insights and having to come into such interesting discussions. And thanks for the generous introduction. So, as everybody know now, Saran has already taken up the introduction part, so I don't have a lot to talk about. But yes, I am associated with Opstray Solutions. I'm working as a lead DevOps consultant there. And apart from that, I also do open source contribution. I have a team where we publish Terraform modules for Azure. We have quite a lot of modules published already. Apart from that, I also publish something called as Azure Bytes, which Saran told about. So that is something which I post every day. So it's just a bite-sized concept or a topic related to Azure. So it can help everybody to avoid going through all the large documents, hours of reading. So with those bytes, you can get a good visual of how that particular concept or topic works, along with all the key pointers to get you started with that particular concept. And apart from that, I am also part of Azure developer community, lead from Gurgaon region. And it's lovely being here again. And in today's discussion, I'll be walking everybody through the Azure infrastructure, Azure cloud as a whole. What all basic concepts are there in Azure which can help you kickstart your journey in Azure, and how can you leverage Azure as a cloud in order to get going in your cloud journey, be it your application development, be it your infrastructure provisioning, and what all are the different ways where we can leverage Azure in terms of provisioning infrastructure. That will comprise of, I'll be walking you through all the manual processes as well, and I'll be talking a bit about the various automation that are available for provisioning your infrastructure in Azure. So with that being said, let's just start off today's session, and I'll quickly start off by presenting my screen. All right. So before we move on to Azure, right, we need to get a hold of why Azure as a cloud came into existence, what all challenges Azure caters to. So in order to understand that, I'll just walk you guys through the entire journey of how on-premises data centers were a thing earlier and how things are progressing towards the cloud infrastructure. What all challenges, what all limitations people face usually in the on-prem data centers these days, considering how fast and rapid the development cycle has grown over the course of years. So our on-premise data centers are nothing but the collection of multiple servers that we used to have in order to facilitate to large compute and storage requirements. So these data centers were nothing but physical facilities where we have been provided with a great capacity in terms of compute and storage that in turns help us in addressing all our challenges and all our requirements for all the compute and storage capacities. So as you can see, this is how the structure of a data center actually looks like. So when we talk about a data center, it is primarily comprised of a compute element and a storage element in its basic and simplest sense. In the compute element, we get all the compute related component that comprises of your CPU capacity, your memory capacity and the networking capabilities. And in the storage segment, we have the capacity, which is the first and foremost component. Then comes our IOPS and servers. So the idea of building on premises or data centers or the entire concept of data centers were introduced in order to get teams and the organizations up to speed, because handling everything on standard standalone systems desktops was not feasible and a scalable solution. So in order to address that solution, the data centers were introduced. And this is how the basic structure of a particular data center looks like. We devise the entire data center in such a manner that we get the best quality of compute and storage all together in a single place. And in that data center, we can onboard multiple users, multiple teams, so that they can work parallelly onto their requirements and their projects without having the trouble to go through their own systems and then facing the challenges of sharing their data across the network or sharing the data on different systems, because that encompasses various security vulnerabilities as well, because when you're working on your personal system there are a lot of items that you don't take into account. However, the data center is more of a controlled environment that one managing authority controls, that usually are your server administrators. So that is how the concept of on-prem data centers or data centers as a whole came into the picture. Now moving on ahead, we talked about the various different type of capacities that are being offered in data centers, right? So just the capacity cannot be enough, right? When we talk about compute capacity, storage capacity, just the capacity cannot be enough, right? There are various different items that comes into the picture, various different other aspects apart from just having the capacity, right? So just having the capacity is like having an empty box, right? Unless or until we start filling that box, or unless or until we start utilizing that box does not fulfill its purpose. And that is the same case with our data centers. So just having the capacity does not enable us to do anything unless or until we start optimally utilizing that capacity which has been provided to us. And that is why we built or started building different services. All right, so the services were designed in order to utilize that capacity. All right, so we have various different services that we build in our data centers. So multiple services were getting deployed on those data centers, and the data centers were the source of hosting all those multiple gigantic applications. So now the organizations broke the chain of limitations of having a single system where they have to manage everything. Now they have one complete data center where they have segregated all the components. They have their machines, they have their databases, they have their applications. So all those components started utilizing those capacities. So they were able to utilize their time, utilize their capacity, their resources more efficiently. This is how the entire concept of utilizing the capacity looks like, right? We already talked about how our data center looks like. So we have our data center. Inside the data center, we were having our compute and storage capacities that were provided. Now the organization started utilizing these data center capacities. So how they started utilizing the data center capacities is by deploying the various kind of services on top of the data center capacity that is available to them. So these services could be virtual machines, these services could be data centers, these services could be your container orchestrator like your Kubernetes clusters, could be database services, could be your app services. And on top of all these components sits our application that a particular organization has built in order to gain business, right? So this application is the final entity. which would be presented to the end user in order to fulfill the requirement of the user and provide business to the organization. So this is how the entire hierarchy looks like. At the bottom, we have our complete capacity. That is what is being provided to us by our data center. On top of it, we have virtual machines. Now evolving on to the next generation, we develop the concept of containers. Over on the top of containers, in order to orchestrate the containers better, we have the concept of Kubernetes and various other services that we deploy on top of our capacities. So the database would be used by our application in order to store the data, user information, any other tangible information that we want to be persisted in the system. So this is how we graph the entire usability of our data center. Now moving on ahead, interacting with the services, right? Now we talked about our data center, that okay, data center requires or provides us the capacity. We have the capacity, that is good. Now we discussed about utilizing the capacity. So in terms of utilizing the capacity, we discussed about deploying various different kind of services in order for us to deploy those services on our data centers, which will in turn start utilizing the resources that we have provisioned inside the data center. Now, once we have deployed all those components on the data center, we want those applications or those services to be utilized as well further. And that is where the interaction part comes in. So in this visual which you are seeing right now on the screen, here you can clearly see we have various different levels of interaction with the entire system. So this hierarchy is something which we discussed already. Now this additional component which you can see in the infographic, that is represented by the tools caption, right? So these tools are various different type of tools that we incorporate in our data center in order to ensure that anybody who is accessing my system goes via certain set of protocols or certain set of tools in order to ensure that whosoever is coming in my system is an authorized personnel and somebody is not just barging in the system, right? So that is why we have incorporated the layer of tools in our infrastructure. So that provides us that security at the infrastructure level. Now moving on ahead, at the top you can see on top of our application we have something called as a firewall. So there also we have incorporated one additional layer, and this layer ensures the security from the application perspective. The end user would not be barging into my infrastructure, but the end user can very well access my application in ways which it is not meant to be. So in order to avoid all those challenges, all those threats, we incorporated the concept of firewall on top of our applications. So as you can see, any traffic that comes via the internet goes through this firewall. Once that filtering is done, the system has ensured the request which is coming onto the application is not a fraudulent request. It's a genuine request. The request passes and the user is able to access the application. In the same concept here, as you can see from the infrastructure component, there are different users, right? So we have the IT admin and we have a standard user. So for the IT admin is the person who is responsible for managing all these tools and the infra accesses. The standard user would be performing a certain set of requests and would be getting a certain set of response based on his roles and responsibilities. So this is how the entire interaction with our data center and the services was designed in order to cater to all the requirements for different users and different administrators. So this is how the entire landscape looks like once we have every single component in place in order to showcase how we are accessing the entire system. Right now we have seen how our data center works, what data center is, how we are utilizing various different capacities, how we are interacting with those services that we have deployed in our data center, right? Now if data center is providing us all those components, right, and still we are moving away from on-premises data centers, there has to be some challenges or there has to be some limitations because of which we started moving on to an alternate solution, and that is where the management of overhead comes into the picture. So with the on-premises data center solutions, no doubt we were having the complete control of the entire environment because I am provisioning everything. However, even if I am provisioning everything, right, there are certain set of overheads and certain set of management that I have to do. And that is what made the organizations rethink their decision of continuing with the on-premises solutions, right? And that is what we'll be discussing now. So the various different overheads and challenges that you see in case of on-premises data center, the first is AD latency and firewalls. So in the previous visual, you guys saw that we had incorporated certain set of additional layers in our system, both from the application perspective and from the infrastructure perspective, in order to ensure that there are no unauthorized accesses either in our data center or in our application. And in order to do that, we have to incorporate the concept of firewalls and active directories. Now, this is something that we have to incorporate ourselves in the system. That means I need to have one physical firewall sitting on my system in order to ensure the application is secured from any unwanted accesses, and I have to set up and manage the entire Active Directory system in order to maintain the complete user database where all the users of my system would be registered, and all those registered users would be accessing my infrastructure or my systems. So that is the area, the Active Directory and firewall components which we have to manage and provision. And if we are provisioning it and we are managing it, that means we have to ensure all these components are working fine. That means the entire ownership lands on my shoulders. I am liable, I am responsible if everything or anything goes down, right? Then comes the latency. Now, since we are talking about on-premises data center, that means there has to be a physical location, right? For example, I have set up my data center in East US region, right? For example, now if I am residing in East US, my data center resides in East US, and somebody is accessing or trying to access the data center from India, for example, they are going to experience latency. That means I do not have multiple points of presence, and that becomes a pretty unavoidable challenge when you are an expanding business or when you are growing your business, because you need to have those multiple points of presence. And in order to have those multiple points of presence, if I started establishing data centers on all those locations, my costs are going to burst the clouds, right? And that is something which we do not want. So these are the challenges which we started encountering. Now, what are the other challenges? Now comes from the base, we started talking about Active Directory, latency, and firewall challenges. These were our base level challenges that we encountered. Now, moving on to the next layer at our infrastructure, right? So, infrastructure. So, while we are talking about on premises data centers, right, that means our physical servers are actually residing inside that particular room or the entire facility which are provisioned. So I have to bear the entire cost of provisioning or incurring that infrastructure. Now, once I have incurred that infrastructure, when a large amount of infrastructure is sitting in one facility, that facility is going to heat up. And then I have to make sure that optimum temperatures are maintained throughout that facility in order to ensure my systems are performing with the well defined temperature ranges. That means I have to incur the cost of cooling and keeping the optimum temperatures in place for my entire facility. Now, in order to run the entire system, I need electricity. So we will be incurring the additional cost of managing the entire electricity connections for the facility, because we cannot tolerate if the electricity goes down or the power goes down, my entire data center would become unavailable. And if my data center become unavailable, a lot of applications, a lot of user base is going to be impacted. And that is something which we do not want to have or experience. And that is why we have to incur the additional cost of managing the electricity, the consistent power supply. And finally is the networking cost. Of course, if we are, spinning up the entire mesh of servers under one single facility, we have to ensure proper networking facilities are also there so that all the services can interact. Plus, all the users who are outside my network can interact with my network, with my infrastructure. So we need to have those physical VPN servers. We need to have everything in our network so that there are no issues while the servers are communicating with each other and while the users are communicating with the servers. So we have to incur that networking cost as well. So we have to incur all these costs. So all this additional cost is something that we have to incur because we are setting up the infrastructure. Now, moving on ahead, we discussed about on the data centers, we were spinning up containers, we were spinning up virtual machines, we were spinning up databases, we were spinning up applications, right? Now, since we are spinning up all those components on our physical data center, that means we are responsible for managing those components as well. Now, when we talk about our virtual machines or our database servers, we need to ensure that patching activities are performed in a timely fashion for those components. Our VMs are properly patched, our databases are properly patched, right? So we have to ensure and we have to put the patching activity in our schedule. We are responsible for doing the patching. Now, since we are providing the virtual machines, we are providing the operating system, that means we have to ensure that the operating system, the machines that I'm providing to my user is free from any sort of software virus. That's why we have to entail those antivirus components into our system as well. Plus, DR is something that is a nightmare for a lot of organizations because when we think about DR, nothing good comes to mind. So, still, we have to ensure that if any anomaly or any calamity strikes the data center, we are in a well enough position to spin up and get all the services up and running. So, we have to ensure the DR component is very well embedded in our entire design of the system, right? And then finally comes our backup. Now, if we are talking about DRs, right, we have to ensure our backups are in place because unless or until we have the backups of our system, we won't be able to perform any DR activities. That would just be a fresh setup for the entire component or the entire system, right? So all these components are on our shoulders. We are responsible in order to manage all these components. And finally, since we have all the system, we are deploying all the applications, we are deploying all the components, we are responsible for tuning, configuring, and maintaining the entire system, right? We are responsible for configuring the database servers that we are providing to our users. We are responsible for tuning in our servers properly so that everybody in the system is having a flawless experience. We are responsible for maintaining the entire system state, that there are no abnormalities observed in the system. So this completes the graph of all the additional management overheads that we get when we talk about physical data centers or when we are dealing with physical data centers. And in order to address all these challenges, we need to come up with an alternate solution where I focus on what is important to me. And being a business, for me, what is important is my application should be available all the time, right? I should be more focused on how my application is behaving. I should not be more focused on how my data center is working if I am having power supply in my data center or not. And that is the reason people started moving from on-premises data center to the alternate solution, which is the cloud. And one such cloud is what we'll be discussing in our today's workshop, and that is Azure. So now finally introducing Azure, and now we'll be talking all about Azure, how Azure comes into the picture, how Azure is able to address all these challenges, what all features and facilities we are getting with Azure, right? So as you all might know, so I'll just reiterate that Azure is an offering by Microsoft. It's a cloud provided by Microsoft, and it is one of the leading clouds in the tech industry. And it provides you with a bunch of features, bunch of facilities that you can utilize, leverage, and accelerate your entire cloud journey. So as you can see, Azure provides you all the major areas, all the major components that you need in order to bring that velocity in your cloud journey. Azure has global presence. It is available in more than 60 regions worldwide. All right, Azure has its own set of security suite that provides you with cutting edge security facilities, be it your Azure Sentinel, Security Center, all the various different security services, Active Directory. So you get a bunch of features out of the box without even worrying about how you have to manage. You just have to start utilizing all those components. And that is the entire essence of going with Azure, right? You do not have to worry about all those management overheads that we were discussing or which we are experiencing in our on-premises data center journey. So now talking about Azure's core services, right? So in this visual, you can see there are a bunch of services that Azure offers, and there is an active addition of services going on. So even at this moment, we have a bunch of new services incorporated in Azure. So as you can see, we have multiple areas divided. We have developer services, we have management services, we have hybrid integrations, we have networking services. So in these broad verticals, Azure has divided its services, right? So that all the various different user groups can start leveraging Azure based on their requirements. So it is very well organized for anybody who is starting in with Azure or who is pretty experienced in Azure to identify which service they want to utilize based on their use case. So all the major services that anybody as a beginner would be utilizing in Azure primarily revolves around your networking and your compute services. So in compute services, you will mostly be working with virtual machine scale sets. And when we talk about containerization, we have Azure Kubernetes services. All right, so we'll be touching base on all those components in a short while. So this is how the graph of Azure core services looks like, and we are still expanding this graph. So there are a lot of new services coming in. Now moving on ahead. So talking about Azure service model. All right. So Azure has three different types of service model. That is IaaS, PaaS, and SaaS. Now what we have been discussing till now is the on-premises system, where starting from the base till the top, everything we are managing. Everything is our responsibility. We have to ensure every single layer of the stack is working fine. Now, when we move on to cloud, when we talk about Azure, right? Azure offers us three different models. First is your infrastructure as service, second is your platform as service, third is your software as a service. Now, when we talk about infrastructure as service, right, all the red areas, all the red tiles that you can see in this infographics, right, all the red tiles are the ones which Azure would be managing, Microsoft would be managing, and all the black ones are the ones that we have to manage. So we can clearly see right from the very first model, infrastructure as service, half of our overheads are taken away by Azure. Networking, storage, server, virtualization, all those overheads, all those management components are already taken away by Azure. We do not have to worry about spinning up the servers. We do not have to worry about setting up the networking. We do not have to worry about how we'll be provisioning the storage with our servers. Azure is taking care of all that for us. The only thing that we have to manage in infrastructure as service is the operating system, the middleware, the runtime, the data, and the application. Right? So when we talk about infrastructure as service, in its simplest sense, the service that you'll be interacting with would be your virtual machines. All right. So when we talk about virtual machines, whenever we are spinning up a particular virtual machine, the only thing that we have to worry about is how the operating system would be there, which operating system which we have to use, any middleware that we want to install in that virtual machine, any runtime that we want, what data we will be putting in the virtual machine, and the applications that will be deploying on the virtual machine. So all those components we have to take care. Apart from that, all the hardware related component we do not have to worry about. I do not have to worry about incurring new CPUs or new RAMs in my system. Azure is taking care of all that. So this is infrastructure as service. Now coming on to the next model, that is platform as a service. Now in the second model, platform as a service, you can see the components which Azure is maintaining, the components which Microsoft is maintaining is even more than what we saw in infrastructure as service. Now in platform as a service, the only thing that we have to manage is the data and our applications. So we'll be deploying the application and we would be responsible for managing the data of our application. We do not have to worry about setting up the operating system. We do not even have to worry about setting up the middleware or the runtime. Everything Azure is taking in account. We do not have to provision anything from runtime to networking. it is already provided to us by Azure. And the final model is your software as a service, SaaS. So in the third model, software as a service, you do not have to worry about anything. You just have to go in, log in, and start utilizing the application. Everything is managed by Microsoft end to end. And the biggest example is Office 365. So in Office 365, it's a SaaS solution. Azure, Microsoft out of the box provides you with all their applications. You just have to go there and start utilizing the application. You do not have to worry about managing anything. So based on your requirement, you can easily select which model you want to go ahead with. Of course, every model has their own advantages and limitations. So if we talk about IaaS model is definitely cheaper as compared to PaaS and SaaS solutions. However, there are certain management components which we have to incorporate. Plus, the other advantage that you get with IaaS is you get a much better control as compared to PaaS and SaaS solutions because you are managing all these components. So the more components you manage, the more control you get. However, the more control you have, the more management you have to do. So this is something which you have to keep in mind. The components you manage is directly proportional to the control you have. The control you have is directly proportional to the overheads that you have to maintain. So this is a simple correlation between the three primary components. So based on those, you can decide which model you have to go ahead with. Platform as a service is expensive as compared to IaaS components. However, the management overheads are reduced. So that is one advantage that you get by opting for platform as a service. When you are pretty sure that, okay, you do not want to do a lot of customizations, you have a pretty set platform where you would like to deploy your application. For example, I have a standard Java based application, or I have a standard .NET based application, and I know that this application would run on Java 11, or this application would run on .NET Core 5 or 7 framework. So I can directly go for my PaaS services, select my runtime, and directly deploy my applications. Finally, software as a service, it is the most expensive as compared to IaaS and PaaS solutions. However, it provides you out of the box applications to directly consume. You do not have to worry about managing anything. You do not have to worry about configuring anything. All right. I hope that clears the cloud service models. Now, moving on ahead. Now Azure is consumption based. Now as you guys already know, we were talking about various different overheads in our on-prem systems, right? On-prem data centers. We have to ensure that everything we are spinning up is our responsibility. That means we would be paying for that. I would be burning a hole in my pocket in order to provision all those components. And that means if I have provisioned one server in my data center, even if that server is being utilized, I still have to pay for it because I have bought it, right? I cannot return it back. Whether it is being utilized or not utilized, that cost is already on. So that is one major aspect which Azure is addressing, and that is Azure is consumption based. That means Azure will only charge you for the interval or for the duration where you are using or consuming Azure services. For example, if I have spun up a virtual machine, I have used it for let's say 1 hour, and then I have deprovisioned that virtual machine. So I would only be charged for that 1 hour. I won't be charged any longer than that. So that gives users a great deal of flexibility in order to how they utilize or how they plan their expenditures, because they have a much better visibility and much more flexibility in terms of how they can route their expenses in order to utilize multiple different services based on their use cases. Now, as I talked earlier, right, Azure has 60 regions, right? All it is present in more than 60 regions. And in this graph, you can see all the presence worldwide that Azure is having. So all these dots which you are seeing here on the screen are the regions where Azure has its presence. And as you can see, Azure has a global presence worldwide. And now Azure is expanding these regions as well. So we have even more regions now. So as you can see, in India also we have 3 regions already. So no matter where you are in the world, you will get the facilities of Azure irrespective of your location. That means Azure has multiple points of presence, and when we have multiple points of presence, that means we reduce the latency factor from our system. Now, this is just how the Azure's global infrastructure looks like. So as you can see, all the area of presences that Azure is having, and all these lines that you're seeing, these are the interconnection of Azure with all these regions. So you can see it is a completely connected graph that Azure is having. All the regions are interconnected, so you do not have to worry about how you will be, migrating from one region to the other. Azure has already defined those connectivities. It has already been taken into account by Azure. So you can see how mature the model is. Now let's talk about the advantages of Azure, right? So we were talking about moving from the on-premises data centers, and there were certain set of challenges and overheads which we were discussing. Now we have to ensure that Azure as the choice of a choice of cloud that we are making should be able to address all those challenges. And yes, Azure is more than capable and is very well addressing all those challenges in a very seamless fashion. So the first thing that comes into the picture is abstraction, right where we were discussing our cloud deployment models, right? IaaS, PaaS, and SaaS. So we were seeing the layers of abstraction that Azure is bringing into the picture. So it is taking away all the different layers of complexities from our system, and it is abstracting them, making it easier for the end user to utilize the infrastructure or utilize the cloud and focus on what actually is important for them, right? Then moving on to the automation. Now Azure offers a great deal of automation in terms of provisioning your entire infrastructure. Now, if I talk about the different areas of automation that you have in Azure, you have two shells that Azure provides you out of the box. One is your cloud shell, the other one is your PowerShell. All right. Then you have ARM based deployments in Azure where you create ARM based templates and you perform your deployment in an automated fashion. You have something called as Azure Bicep. Azure Bicep is closely related to Terraform. If you would like to have some insights on how Azure Bicep works, I've already done a workshop on Azure Bicep, how it works, how it functions. So you can just, very well go ahead and check that workshop out. And then we have Terraform. So Terraform is the open source ISE platform, and Azure is very well integrated with Terraform as well. So you have all these options in order to choose from how you want to do your cloud journey in terms of automation, in terms of automating your entire infrastructure. So you have more than, close to four, five options in order to automate your entire infrastructure. That is really high. So that means you have a lot of choices to choose from. Then comes the security component. Now Azure is highly secure in itself. Azure provides you great deal of security in terms of be it managing your identities, be it managing your applications, be it managing your infrastructure. So Azure provides you with a great level of security in all those layers, right? Azure has multiple set of security solutions in its arsenal which are more than capable enough to cater to all your security requirements. So Azure has the services such as Azure Security Center, Azure Sentinel, which is a complete SIEM based solution, which works on AI. It helps you not just detect any sort of threats in your system, it also helps you remediate those threats using the AI engine working backend. All right. Then Azure also provides you out of the box WAF based solutions. So now we know that we are in a era where everything is on the web, right? Everything that you have to access is usually accessed in the sort of web applications. Now, in order to ensure the security of those web applications, Azure provides you with these solutions where you get WAF out of the box. For example, front door, for example, application gateways. These services comes with WAF enabled out of the box. So that means you're not just load balancing your solution, you are ensuring the proper security of your application as well. All right. Then we have governance. Now you have a very matured solution provided by Azure in terms of how you set up your governance. And when we talk about governance, we have something called as Azure policies, right? So Azure policy is one of the very handy services that Azure has in its arsenal. Using policies, you can define how you want your cloud to be accessed, how you want your cloud to be managed by different users or the administrators, right? So, for example, if I want to utilize just one single region, if I only have my presence in India and I want all my resources to be deployed in India, I can very well have a policy deployed, and that policy will ensure that there is no resource provisioned outside of the Indian region. So, this is how simple it is to provision governance in terms of Azure. Plus, you have the standard components, the functionality of tagging. You have something called as resource groups. Now, resource groups is a very innovative concept that was introduced by Azure. That is unlike the other components where you are just having all your resources out there. And if you have to search any resource, you have to either type their name or you have to go through the entire list of services that you have deployed. You can very well group all your services based on your resource groups, and inside a particular resource group you will be able to find all your services. And this is how in different ways Azure is bringing in governance so that you get better control of your environment. Finally is the management. Now Azure takes away all the management overheads from you. That means you do not have to worry about managing your infrastructure. You do not have to worry about managing your facilities. You do not have to worry about managing the power supplies, the network configurations, the patching, the upgrades, the firewalls, the antivirus, anything. You do not have to worry about anything at all. All those management overheads are being taken away by Azure, and Azure is responsible for managing all those components. So, in terms of management, you are pretty light-headed. The only thing that you have to focus on is how you want your application to function. So, anything that actually matters to you, you will be only focusing on that. And these are some of the primary advantages that Azure brings into the table. All right. And with this, we mark the closure of introduction to Azure. Now, this area, this component was explicitly designed in order to give you guys a hold of how Azure, looks like, what Azure is, what all challenges Azure would be catering to. Now we'll be moving on to the next segment, that is the basics of Azure, where I'll be walking you through all the various different basic services that Azure has to offer and how you can leverage them. And then finally, I'll be walking you through the portal to give you a look and feel of how Azure portal looks like, how easy it is to provision any single resource, and all that. So now moving on ahead, I hope my screen is still visible, right? All right. So now moving on ahead, the next component is the basics of Azure. So now when we talk about the basics of Azure, the first thing that we'll be discussing would be the primary features of Azure. In the earlier concepts, we discussed what Azure is. We discussed how Azure is catering to various different problem statements and what all advantages Azure is bringing on the table for us. Now let's discuss a bit about what all primary features Azure brings for us. There are a bunch of more features. However, for this workshop, I have selected the primary features that I feel like are very crucial for everybody to know. So the first and foremost thing is high availability. Now, when we're talking about our on-premises data center, right? We were discussing about the points of presence, the latency component, right? The area of availability. So that is something which becomes very crucial when I am working as an organization. I want my application, I want my system to be available throughout. I do not want to lose a single second. I do not want to lose a single minute in terms of availability. And that is what Azure provides you. Azure provides you high availability in different formats. We have different regions, we have different zones, we have, services that gives you high availability out of the box. For example, you have virtual machine scale sets, you have web apps as your web services, you have something called as Azure Kubernetes services. So Azure is providing you various different aspects with which you can achieve high availability. All right. That means we are able to maximize our services accessibility using Azure. Now, the second component is Fault tolerance. Now, when we talk about high availability and fault tolerance, there are a lot of times when we can intermix these terms, or we use these terms interchangeably. That high available, a highly available system, that means a fault tolerant system. That is not always the case. High availability is different. Fault tolerance is different altogether. Right? High availability ensures that your service is accessible throughout. However, fault tolerance ensures that there is zero downtime in your system. That means if I have an infrastructure provision, even if, let's say, a particular data center goes down, still my system will not experience any downtime because I have a replication going on in another zone or another region. All right. That is what fault tolerance is, and that is what Azure provides you. We discussed earlier, right, that Azure is available in more than 60 regions. Now, in all those 60 regions, Azure has three availability zones everywhere. So, in every region, you will be getting three availability zones. That means within a particular region, you will have at least two replications available for your entire infrastructure, your entire application components. So, that gives you the confidence of being a fault tolerant system, or bringing or making a fault tolerant system, and that is what Azure is providing you. Then comes our disaster recovery. That means disaster recovery means if any natural calamity happens, if any disaster comes into existence, we should be able to restore to our normal operations as soon as possible, and that is what Azure is providing you with its best in class replication functionalities, with its best in class backup features. You get all your data replicated, stored in a secure location, so that even if your entire system goes down, you will be able to come back up with minimal operations, with minimal downtime, with minimal unavailability. Plus, as we talked earlier about a fault tolerant system, so with Azure, you can very well build that entire fault tolerant system, so that if at any given point of time you are facing a disaster situation, you will still be available in a different region, in your secondary region. So you do not have to worry about any downtime. Plus, if you are not taking up, the replication or the functionality where you'd be available in a different region because of various different aspects, still with its replication and backup functionalities, you can come back up within no time. Now the next component is scalability. Now we were discussing about our on-premises data centers, right? When if we have bought in a certain piece of hardware, whether it is being utilized, not utilized, I still have to pay for it. And let's say I have brought in one server. That server is running my application. Now I am seeing a sudden spike in the requests. My system started growing. My application became popular. People started using my application. Now what happened is I started experiencing a lot of traffic on my system. Now the application is running on one single server, right? Now in order to cater to those growing requests, I need to have another system running parallelly. For that, what I have to do is I have to buy another system. Azure is taking away all those overheads from you. Azure provides you great deal of flexibility in various different services it offers, right? For example, if you are working with compute-based services, so Azure provides you the concept of scale sets, where based on your increasing requests, you can easily scale up your system or easily scale down your system. So scaling up your system is just a matter of seconds in Azure. As soon as your system experiences increased traffic or increased number of requests, Azure will seamlessly upgrade your system or scale your system out in order to cater to all those increasing requirements. So you do not have to worry about manually scaling your system. The final component is elasticity. Now we talked about scalability right now, right? When we talk about scalability, that means our system should be able to grow with the growing requirements or the growing requests that a particular application is experiencing. Now, once that surge is passed, right? That means, for example, I was having some, big billion day or, great sale going on, or there is any, great event that I am hosted on my application, because of which there was a lot of traffic coming in my application. Now, once that event is done, that means my traffic will boil down to its original state. the rise in my request, the rise in my system accessibility will go down to its normal business as usual state. Now, once I have reverted back to that state in terms of the number of requests, my system should also be able to revert back to its previous state. Because when I was working with 100 requests per second, for instance, one server was enough. Now, due to some event, my request rate went up to 500 requests per second. And in order to cater to those requests, I spun up two servers. Now, once that event is done, my request rate has fallen back to 100 requests per second. But I'm still having two servers running. That means I am in an over provisioned state. So my system should be intelligent enough that if that surge has gone down in terms of the number of requests, my system should be able to scale back down from having a two system or two machine based system back to one machine based system. So from two systems, I should come back to the one system state. And that is what the concept of elasticity dictates. And that is what Azure provides you. So I'll just quickly show you as well. We have draw.io. Just to give you a better insights on how the concept of scalability and elasticity works. All right, so we were talking about our system. Let's say this was our system. I'll just keep it slightly bigger so that VM, or let's say this is our server 1. All right, and in the same fashion, we'll use this in a later state. Now there is some traffic coming on my system. All right, let's say currently I am having 100 requests per second. All right, that is my usual workflow. Now what happened is, in the next scenario, instead of 100 requests per second, it became 500 requests per second. And in the same fashion, the requests would come onto my system. Now Azure is intelligent enough that it helps you design the intelligent system which is able to scale up automatically. So as soon as I start experiencing 500 requests per second in my system will automatically scale. So here I have server 1. So one more server would come into the picture. That is server 2. So as you can see, my system automatically scaled. All right, so here Azure automatically scales the system, and this is the entire concept of scalability. Now let's move on to the next concept that we discussed, which was elasticity. All right, now this was the initial, the new state or the current state of my system. Now what happens is my request has dropped back to 100 requests per second, let's say. Now instead of 500, I'm back to 100. The event is done. It was a success. Now what will happen? Azure will automatically scale down. This is elasticity. So my second server, which Azure spun up, will go away. and just my first server, that was my initial server, would remain. So this is what I mean by the concept of scalability and elasticity, and this is how Azure makes the concept, the entire notion of scalability and elasticity so seamless for you that you don't even notice it. That when your servers were increased in terms of handling, in terms on handling higher requests, and when it came back to normal. So now coming back onto our presentations. So now let's move on ahead. So we just discussed all the features. Now the regions and zones. As we already discussed, I gave you some gist of regions and zones. Region is the actual geography where Azure would be having multiple data centers. All right. For example, so this would become our region. Region, that is an actual geography. All right. So region is the actual geography where Azure would be deploying its multiple data centers. Azure's multiple data centers would have their presence. And inside a particular region, we have zones. I'll just increase it a little more so that we can accumulate the zones. So this is my region. This is my region. And inside the region, we will be having zones. And as I told you earlier also, inside every region, Azure has 3 availability zones, and that is what we'll be marking here. Zone 1, Zone 2, and Zone 3. Alright, so this is how the geography of Azure's regions and zones looks like. And these zones are nothing but your data centers. All right. So this is how the geography works. So whenever you will be deploying any resource in Azure, it will fall under a particular geography. That means it will be falling under a particular region. And inside that region, you'll be selecting in which zone that resource would be deployed. Now you have multiple options whether you want that particular resource to be deployed in a single region, or if you want a high available system, then you will be marking the replication of that particular resource on multiple zones. All right. So this is the entire concept of regions and zones in Azure. Now, consumption-based pricing, we already discussed. Azure is consumption-based. That means Azure only charges you for what you are consuming. All right. That means if I have consumed a particular resource for 1 hour or 2 hour, I'll only be charged for those 1 or 2 hours where I'm consuming that particular service. Now it has, on a broader scale, it has two models. One is pay as you go, the other is enterprise agreement. Pay as you go is the standard payment model that we just discussed. You use the resource and then you pay the bill. That's as simple as that. In the enterprise agreement, it is more for the larger enterprise, the organizations, when you have a larger commitment with Azure and where you will be having a considerably large amount of expenditures. All right, in those cases, Azure has the concept of enterprise agreements where various different enterprises or various different organizations get good amount of discounts on their long-term engagement with Azure. So you are eligible of getting up to 60 to 70% discounts in your services based on your enterprise agreement. That is something which is for bigger enterprise or the organizations. All right. So these are the primary pricing models in Azure. Now, in cloud deployment models, we have 3 different models. First is your public cloud, then your private cloud, and your hybrid cloud. Now we discussed about IaaS, IaaS, PaaS, and SaaS. Now these are public, private, and hybrid cloud. Now, what is a public, private, and hybrid cloud? When we talk about public, private, and hybrid cloud, right, it is pretty simple. It is just our data centers and how they are being managed. So, if I am deploying everything on cloud, right, everything on a public cloud, for example, I have deployed everything in Azure, right? So, all my resources, if they reside in Azure, that means I am following the public cloud model. Everything is on my public cloud here. All right. Now next comes our private cloud. So in the private cloud, what happens is public cloud, as the name suggests, it is public in nature. That means it would be accessible to the external entities also. I can log into Azure. All right. However, when I talk about a private cloud, that means I own that entire cloud. Nobody can share resources in this space with me. Here in this public cloud space, I am having my resources. Apart from me, multiple other users are also utilizing this space in order to spin up their resources. For example, just to give you better clarity, resource 1 belonging to user 1. All right. And then we have resource 2 belonging to user 2. So on and so forth. So this is what the concept of public cloud is, that you are sharing a common space where not just you, apart from you, multiple other folks are deploying their services and managing their applications. All right. Now comes your private cloud. In private cloud, you have the complete control of this entire space. It is very close to how we were discussing about our private data centers or on-premises data centers. And as I mentioned earlier also, right? When we talk about on-premises data centers, we were having the complete ownership, right? We are responsible of what we are deploying in the center. So this is what the concept of private cloud is. So in private cloud, we will be having the concept where everything would be belonging to one user or a set of users. Everything would be for user one only. And then comes our hybrid cloud. Now in hybrid cloud, what happens is we are making use of the public and private facilities both. So just to make it a bit more simple, I'll just show a demarcation here. So it will be easier for everybody to understand. So here instead of private cloud, we have hybrid cloud. All right. So that means one part I am utilizing from the public cloud, the other part I'm utilizing from the private cloud. So that means here when I'm utilizing the public cloud part, in the public cloud part, we'll be having the same paradigm, multiple different users, multiple different organizations sharing one common space. Then I have my private cloud part. So in the private cloud part, everything that I have explicitly belongs to me only. All right. So this is the entire concept of public, private, and hybrid cloud. And this is how all these clouds differ from each other in terms of various different functionalities they have to offer. So now moving on ahead.
Actually, Naveen, sorry for interrupting you.
Yes, please.
Yeah, actually, yeah, uh, they told you, yeah, do you have any queries till now? Yeah, if you have any queries, we can address it.
Yeah, sure. If there are any queries, do let me know. And if you have any queries or you want to discuss it at the end, you can just mark it in the comment section. I'll take it up in the last 15 minutes.
Yeah, that's great. That's great. Okay, Naveen, you can go ahead. I hope so. No
All
problem.
right, thank you. So moving on ahead, now we'll be touch basing upon the various different services that Azure has to offer. So here I'll be discussing the most commonly used services in Azure. The first and very foremost service would be Azure networking services. And in the networking services, the very first component that we have is our virtual network. The virtual network in Azure is similar to your actual physical network that we have on our actual data centers. So there you would be provided, or you will be spinning up a virtual network that will comprise of a larger address space where you will be deploying your other resources, other networking resources, for example, your subnet, your virtual machines, so on and so forth. Inside the virtual networks, what we have is called a subnet. Subnet would be the smaller chunks that we will be deploying inside our virtual network. So the hierarchy goes something like this. We have our virtual network that will give us a larger address space. All right. Now inside the virtual network, we can have multiple subnets. So subnets also provide us with the address space. However, this address space that a particular subnet will be having is derived from the address space of our virtual network only. Subnet, it would be having, let's say, 10.24. Alright, so in the same fashion, I can have multiple subnets. And inside the subnet, we will be actually deploying our resources. For example, my virtual machine. And this virtual machine would be assigned an IP. And this IP would also be derived from my subnet, which in turn is derived from my virtual network. And this is how the entire networking component looks like in Azure. So we have our virtual network. Inside the virtual network, we spin up multiple subnets, and inside the subnets, we spin up our networking instances, be it our virtual machines, be it our virtual machine skill sets, so on and so forth. So now the advantages of VNet, as I told you, it is virtual in nature. That means I do not have to worry about buying or incurring any physical devices in order to provision such address spaces for me. The only thing that I have to do is I just go onto the portal. I just have to go onto the portal, and this is how the portal look like. So now I'll just quickly walk you through the portal as well. This is how the portal looks like when you log in. All right, here in the search bar, you can simply just type virtual networks. Here you will get the service of virtual network, and with the single create, we can simply go ahead and create our virtual network services. All right, you just select your subscription. You have your resource groups. So as I told you about the concept of resource group, that is the logical entity under which we can group all our resources. We simply name our resource. We define the address. We define the region from all the available regions. We simply go on next. Security, if we want to enable any specific security component, we specify the address space of our virtual network. If we want, we can change it as well. That is completely up to us. All right. And then we simply go review and create it. And while you are creating your virtual network, as you can see, you will get the option of creating the subnet here itself. So if you want to add your subnets while creating your virtual network, Azure completely gives you that freedom, and you can very well do it with great ease. So you just simply have to click on add a subnet. Here Azure will provide you all the details that you have to fill up. You simply fill up those details and you're good to go. All right. So this is how you spin up your entire network, and this is how simple it is. So the primary advantage being you do not have to worry about incurring any physical devices. You do not have to worry about how you are going to provision the entire network. You do not have to worry about how you are going to mask your subnets. Azure provides you by default mask, so it will help you provide the understanding of how many address spaces you'll be getting. As you can see, it is clearly providing that with this address space or with this mask, I'll be getting around 65,000 odd addresses. All right. So you do not have to go through all those calculations. Azure is doing all that for you. Subnets is something that we already discussed. Subnet falls inside our particular virtual network. Now coming on to the NSG component. NSGs are network security groups. So whenever we are defining our virtual network or our subnets, right, we need to have certain set of mechanisms in place which can filter out the network traffic for us. All right. If I just keep it as it is, anybody can enter inside my network, right? My network is exposed right now. It's vulnerable. Now, in order to avoid that, Azure gives you the concept of NSG or network security group. All right. Now, this network security group is something which you can apply at the subnet level, or if you want, you can apply it at your virtual machine level as well. That means, for example, if you are having one subnet which is comprising of your application virtual machines, application servers, that means all those servers are going to have similar similar networking rules. That means the port 80 or their internet port would be exposed. SSH access we want to deny. So we can have one single NSG placed on top of the subnet, and those rules would be applicable to all the servers inside that subnet. All right. Now let's say we have a subnet where we have virtual machines which are serving different purposes. So for that, in order to cater to that scenario, instead of enabling the ports at the subnet level, you can granularize this security policy by applying the security group at your virtual machine level. All right. So at your different virtual machines, you can apply that security group and it will act for that particular virtual machine only. All right. And this is how NSGs work. Now moving on ahead, we have IP addresses. As I already talked about, whenever we are provisioning a network resource, a particular IP would be allocated to that resource. And there are primarily two different type of IP addresses. One is your public IP address, the other is your private IP address. So private IP address is something that you get out of the box when you are provisioning a particular virtual machine. All right. However, the public IP address is something that is completely up to you whether you want a public IP address to be enabled or not for your machine. That is your call. So while you are creating the virtual machine, you can decide whether you want to have a public IP or not. If you are having a public IP, that means your virtual machine would be accessible to other people outside the network via that public IP address. Using the private IP address, nobody from outside the network can access this virtual machine because it is completely concealed within this network. However, if I am assigning another public IP to it, 20.30.48.10, so if this public IP is attached to this virtual machine, that means anybody outside this network can access my machine and they can access it via this public IP. And this is the concept of IP addresses. Now the other service that we have, which is very widely used, is load balancers. Now we talked about the concept of scalability, right? When we are scaling out, when we are scaling our system out, we need to have something in place which can help us standardize the way traffic is coming into my system. If I am having 10 machines serving one application, I cannot just go around, sharing the IP of all those 10 machines. I need to have a unified source of entry for that traffic inside my network. And that is where the load balancers come into the picture. All right. So using the concept of load balancers, we can have multiple virtual machines or multiple servers or applications running at the backend. However, the user will only have one single point of entry, and that single point of entry would be the IP address of my of my load balancer. And using the IP address of my load balancer, the user would be able to access my application. And Azure do provides you various different categories of load balancers. You have your standard load balancer, you have your global load balancer, you have your application gateway, you have your traffic manager, you have your front door. So these are the various different load balancing solutions that Azure provides. So if I talk about the standard load balancer, your standard load balancer works within the same region, within the same network for the resources inside one single network itself. When I talk about the global load balancer works on the IP addresses. However, it is able to cater to various different networks spread across various different regions. So that is the concept of your external load balancer or your global load balancer. However, you have to keep in mind if you are using the global load balancer currently only supports the public traffic routing. It does not support your internal traffic routing. So if you have your internal traffic which is coming from multiple regions, you cannot use global load balancer there. All right. Then we have our application gateways. All right, so I'll just write them down also. We have standard load balancer, we have global load balancers, then we have application gateway. Application gateways are the advanced version of your standard load balancer, where the standard load balancer works on the IP and port based protocol. It completely works on your host based protocol, path based routing it supports your WAF. Alright, so these all additional functionalities it provides you. All right. Now, after application gateway, we have something called as traffic manager. Now, traffic manager serves you globally. Plus, it also helps you set up your DR or active or active passive setup. Active or active passive setup. Plus, you can also do geo-based routing using traffic manager. That means if you, for example, you have two infrastructure, one system is running in, East US, the other one is running in Central India. So you can very well control how you want to route the traffic. For example, I want if any traffic is coming from East US, it should go on the infrastructure that is deployed on East US. If any traffic is originating from India region, then the traffic should go on the Central India region. So you can do that geo-based routing as well using Traffic Manager. Then finally we have front door. Now front door is completely, your DNS based routing solution. It provides you WAF on top. Application gateway is not your, it does not provide you out of the box the host based, or DNS based routing. You have to have your custom DNS which you can incorporate in application gateway. However, front door on the other hand completely works on DNS, completely works on the HTTPS protocol, provides you WAF out of the box. Traffic manager, however, is a global solution, still works on your HTTP protocols. Same goes with your application gateway if you are not configuring a custom host or custom domain here. All right. So the primary difference that you get in application, your traffic manager and your front door is traffic manager works on your HTTP based protocol. However, front door completely works on your HTTPS based protocol, and it provides you the functionality of WAF out of the box. Traffic manager, however, does not provide you the concept of WAF. So these are some of the important items that you have to remember or keep in mind while you are finalizing your load balancing strategies or your load balancing solution. So moving on ahead, categories of load balancers, that is something that we have discussed in great detail just now. Now coming on to Azure Compute. In Azure Compute, the first thing that we have is virtual machine. Virtual machine we already discussed are nothing but your virtual machine or your server instances that you can easily spin up in Azure and get your functioning going. The second component is your skill set. Now, when I'm working with a virtual machine, right, I have a limited capacity, I have a limited compute capacity where we cannot scale out. We discussed the scenario of scaling and elasticity, right? Where if I am just using a single virtual machine and if my traffic increases, I cannot just, magically increase the number of virtual machines here. I have to spin up one more virtual machine from scratch and then I'll be able to cater to that traffic. However, if I am talking about virtual machine scale sets, virtual machine scale sets provide you the functionality of auto scaling out of the box. That means you can define your custom rules, and based on those custom rules, Azure will automatically and intelligently scale up or scale down your system based on the traffic conditions it is experiencing. All right. This is the concept of virtual machine scale sets. Now, auto scaling, this is how the auto scaling works. All right. The VMSS auto scaling, which I just discussed with you, where you define your rules. This is how you do it. You have your resource matrix. That means resource matrix is your CPU utilization, memory utilization, all those components. Time is the interval during which we want these matrix to be cross verified with the rules that we have defined. So we define the rules, and here, as you can see, right, in these rules we can define, let's say if my CPU threshold crosses 70% or my memory consumption goes above 80%, scale up. All right, so what we can do, we can have multiple actions incorporated. It's not just we have to increase or decrease the size of our VM. We can have custom actions. For example, if something happens, if my CPU utilization goes above 70%, I should get an email. So we can very well configure an email. Or we can also configure a webhook that will in turn trigger a third party action. Let's say I want to trigger a function app, I want to, trigger another application, or I want to trigger another third party API. That is something which you can very well do with great ease. So with these auto scaling rules, you are not just limited to scaling up or scaling down your VM instances. You have the complete freedom and flexibility of defining your custom actions, such as shooting out certain set of emails or performing certain set of webhook actions. Now, in type of scaling, we have two major type of scaling. We have horizontal and vertical. So if we talk about horizontal and vertical scaling, so what happens is, when we talk about virtual horizontal or vertical scaling, right? First, we'll discuss about the vertical scaling. So what happens in vertical scaling is, let's say this is one instance that I have, VM1. All right, currently it is running on two CPU 4 cores. Sorry, two CPU 4 gigs of RAM. All right, this is the current configuration of my system. All right, now what happens is the traffic increased. All right, it is directly connected with the internet. The current traffic that I'm experiencing is, let's say, 100 requests per second RPS. All right, and I'm having one single system. Now let's say this traffic increases from 100 to 400 requests per second. All right, now I am experiencing certain set of lag in my application, how it is being delivered via this one single machine. So when I will be doing vertical scaling, what I will be doing is I will be increasing the capacity of this virtual machine. That means instead of two cores, I will make it 4 cores and 8 gigs of RAM. All right. Now it can very well handle the 400 requests per second. So what is happening is, in vertical scaling, we are increasing the capacity. All right. Plus, it has two major limitations. First, there is a certain extent up to which you can increase the capacity of a machine. There is an upper bound to the extension. Second is, whenever you are doing vertical scaling, there is a downtime, because the system has to restart. The system has to restart in order to take effect of the newer configurations that we have configured. Now, in the same fashion, let us talk about horizontal scaling. All right, this was our same VM, which was running on 2 cores and 4 gigs of RAM. Now my request count has increased from 100 to 400 RPS. Now in this case, what I have done is, I'm not increasing the capacity of this machine. What I'm doing is I'm simultaneously bringing up another machine in parallel with the same configuration. All right, so here what is happening? So here I am simply associating my traffic with this virtual machine. So now my traffic is not just going on one single virtual machine, it is being served by two virtual machines that I have provisioned. So in this case, I have horizontally scaled. That means I have scaled out. In the vertical scaling, I was scaling up. In the horizontal scaling, I'm scaling out. So what happens is, in horizontal scaling, we are increasing the number of machines. Plus, unlike your vertical scaling, horizontal scaling does not have these limitations. There is no upper bound of the extension and there is no downtime. However, there is the cost factor, which is there in vertical scaling as well. However, when you are dealing with multiple instances, that is considerably high when we talk about increasing the capacity of one single system. All right. So this is how vertical and horizontal scaling works. Now coming on to Azure Storage. So Azure Storage is the service where we get the storage capacities, where we can store different type of objects, different components into Azure. So Azure Storage is comprised of primarily three items that we'll be discussing. So this would be our storage account. So when we talk about storage services, so Azure provides us with the storage accounts, and inside the storage accounts, we can spin up different type of storage services. So what we have is we have blobs, we have Azure Blob Storage, we have file shares, and we have tables. So these are the three primary type of services, storage services that Azure provides us with in order to cater to various different kinds of requirements that we might have. So we have Azure Blobs, then we have file shares, and then we have tables. Alright, so when we talk about Azure Blobs are primarily meant to store all the unstructured data. All the unstructured data, and there are multiple different type of blobs. All right, blobs 2 in itself has a different set of categories. We have page blobs, we have append blobs, we have block blobs. That is something which would be the topic for another discussion, where I might be discussing storage in detail. So it is responsible for storing all your unstructured data. So now, be it your audio files, video files, text files, anything and everything that is unstructured in nature, you can easily store in Azure Blobs. All right. Plus, Azure Blobs are very secure. You can have security policies enabled at your storage account level as well as your blob level. So that is completely up to you, and that is pretty seamless in nature. Then we have our file shares. So file shares, as the name suggests, are file shares provided by Azure, where you would be mounting the drives from Azure or a particular file share from Azure onto your physical servers or your virtual machines. So in order to enable faster file transfers rather than going over the internet, you can very well easily mount a file share onto your server or your virtual machine, and you can easily store that data onto that file share. And as soon as you have that data copied or moved to the file share, mounted on your server, it will automatically reflect in Azure's file share as well. So you do not have to manually go and move that file shares data to Azure file share. All right, you simply mount a file share in your server. All right, and then finally we have tables. So tables are just like any other, relational database that you might have heard about or you might have worked with. So in the same fashion, tables also work, but they are not that extensive in nature, unlike the other database engines. They are optimal for performing any standard or normal relational RDBMS operations. And then we have one more service. All right, that is called a queue. So Azure Storage Queue, just like any other messaging service that you might have worked with in this similar fashion, this storage queue service also works. Now you can integrate these queues with other services in Azure. So Azure queues provide you that functionality where you can integrate these queues with some other, let's say, Lambda functions or some event hubs, where whenever a message comes inside this queue, a particular event would be triggered. All right. So these are all the primary offerings of Azure storage services or storage accounts. So in detail, we can discuss it. Maybe I can have another session where I'll be discussing Azure storage in detail. So these are all the services which Azure provides you in terms of storage, and this is pretty extensive in nature. You are getting storage for unstructured data. You are getting storage for files. You are getting storage for your queues, messages. You are able to store all your relational tables or your relational data inside Azure storage accounts, and you can very well query this data as well. So these are all the functionalities which you are getting out of the box in Azure. You do not have to do anything explicit in order to get access to these functionalities. These are available to you from day zero. All right, so blob storage, file storage, table storage, queue storage, these are all the components which we just discussed. Now moving on to the final component of the day, that is Azure DevOps. Now Azure DevOps is one of the very popular offering that Azure offers. It was also called Team Foundation Server or TFS or VSTS earlier. Now it is called Azure DevOps. So Azure DevOps is a complete platform in order to cater to your entire DevSecOps requirement, starting from your triaging to your final builds, releases, and deployments. So it is a one-stop solution for all those aspects that you get. And unlike other CI/CD tools that are available in the market, which provides you just one single component. For example, if I talk about Jenkins, right? Jenkins is something that has been widely used in the community and has been used for lot of years now. I have also personally used Jenkins a lot. However, Jenkins is limited to providing you the functionality of CI/CD, right? And that is something which you have to configure, and then you will be able to do it. Azure DevOps, however, is enabling you to do all those components and even more with just a single platform. You can very well perform your entire builds, releases, and deployments. You can have the entire approval mechanism out of the box. You do not have to write any special logics for that. You can very well store your secrets in Azure DevOps. You have your repositories, Azure Git repositories integrated with Azure DevOps. That means you do not have to worry about hosting your code somewhere else in some other version controlling system and then utilizing Azure DevOps for your DevSecOps lifecycle. You have Azure repositories integrated and it supports both your distributed and centralized version controlling system. So you have support for Git and VSTS both. All right. Plus, Azure also gives you the functionality of performing entire project management. That means you might have heard about or worked with Jira's and Trello's, right? So, what all functionality you are getting in Jira and Trello, you are getting all those functionalities in Azure Boards. Azure Boards provides you the entire capability of project management where you can do everything from team planning to your sprint planning, to representing your Kanban boards, creating dashboards, anything and everything you can do there in Azure boards. So Azure DevOps becomes your one-stop solution where you can do everything starting from project management to your actual DevSecOps life cycles and platform engineering under one single umbrella. And if you want to know more about Azure DevOps, I have already done one extensive session on Azure DevOps. So you can, just go ahead, check it out, go how Azure DevOps works. So there I have explained every single concept in detail in Azure DevOps, what organizations are, what projects are, repositories, pipelines, boards. I also have done the extensive workshop where you can learn how to design your pipelines in Azure DevOps. So you can, very well go ahead and check out those videos that I've done. And with this, we mark the closure of our session today that comprises of the entire overview of what Azure is, how Azure is, enabling you to perform more, how Azure is catering to all your different problem statements, how it is, taking you beyond what you're already doing. So that is all for today's session. And thank you so much, guys. It was great delivering this session. Plus, if you want to connect with me, you can very well connect with me on LinkedIn. I'm on Twitter, and if I just show you these slides, so here you can get my Twitter handle and my email and my LinkedIn handle. So I'm available by the same name, Naveen Verma, on LinkedIn. So you can reach out to me on LinkedIn. I would be more than happy to connect with you guys, discuss if you guys have any queries regarding DevSecOps, cloud. I'd be more than happy to connect with you and discuss it over. Plus, I also have a YouTube channel called, Adroitness of DevOps. So if you want and you like to follow DevOps and cloud, you can check out my channel. However, I have recently developed that channel, so it is not having a lot of videos. But yes, I'll be posting a lot of concepts, topics there. And apart from that, I do post Azure Bytes, something called as Azure Bytes, which looks something like this. All right, it's a bite-sized post containing of a particular concept or a topic that you can, go through in less than 5 minutes and have a good hold of that particular concept or a topic without, spending hours on reading the different documentations. And I post these bites every day on my LinkedIn handle. I'll just quickly show you guys as well my LinkedIn handle. So this is my LinkedIn handle, and here I do all those posts. I you know try to post anything and everything that I find intriguing or anything that I discover new in DevOps cloud space. So you guys can very well connect with me. I'll be more than happy. So with this, I'll mark a closure to this session. Thank you so much. And thanks, Aaron. Thanks for having me here. Thanks for hosting me. It was a pleasure.
Yeah, and I mean, it's been a wonderful session. I mean, yeah, thanks for sharing your insights with us. And it will be a great session for the starters who wants to start their journey towards Azure infrastructure as well. Actually, it's been a great insight we
Sure.
learned from you, and actually, your bites really I'm amazed about it. Actually, every day morning, uh, when I'm opening the LinkedIn, I will first see your bite, and then only I will actually continue with another post as well. Like, it's been a great thing that you have that commitment towards posting a bite every day. As you told earlier, instead of going to a complete blog or something, these bites are really helpful and yeah, it's really an handy one for us to know what is happening in a shorter way with some diagrams as well. So keep up your good work going, Naveen, and I'm really happy and actually I'm glad to have you in my show. And I'm really thank Lakshit, Saptak, Rahul, and Azure developer community for giving a chance to host this session for me. And also, thank you for accepting my invitation at short notice and delivering a very good session actually on this topic.
It's a pleasure. It's a pleasure, Sir Sharon. And thank you so much for hosting me. It's a pleasure, having a discussion with you, coming in on this show, and the community is anyhow wonderful.
Yeah. Okay, Naveen. Yeah, actually, yeah, now we'll we'll get some queries. I hope so actually from the crowd. So we can connect with them and we'll see if there is any query we can address or we can wind up the session. Okay. Uh,
Sure.
Anyone, if you have a query, you can you are free to post now and actually have a word with Navin and Navin will help us to clarify the queries from the guys there. And still we have 15 minutes or if you want to yeah ask any concepts which are related to Azure infrastructure also, Navin can give you guys. Is there anyone? Okay, no one was posting the queries, Navin. And Navin, once again, thank you for accepting the invite and coming and accepting the very good things.
Sure,
Okay,
sure.
related to Azure infrastructure. So we are
Definitely.
winding up this show, and we meet you definitely in another show with regarding to Azure infrastructure part. Okay.
Definitely.
Thank
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 you.
you so
Thank
much,
you so
Navin.
much.
Thank you everyone. Thank you, Lakshmi. Thank you so much. Thank you so much.